Hydraulics is a topic in applied science and engineering dealing with the mechanical properties of liquids. At a very basic level, hydraulics is the liquid version of pneumatics. Fluid mechanics provides the theoretical foundation for hydraulics, which focuses on the engineering uses of fluid properties. In fluid power, hydraulics is used for the generation, control, and transmission of power by the use of pressurized liquids. Hydraulic topics range through some part of science and most of engineering modules, and cover concepts such as pipe flow, dam design, fluidics and fluid control circuitry, pumps, turbines, hydropower, computational fluid dynamics, flow measurement, river channel behavior and erosion. Free surface hydraulics is the branch of hydraulics dealing with free surface flow, such as occurring in rivers, canals, lakes, estuaries and seas. Its subfield open channel flow studies the flow in open channels. The word hydraulics originates from the Greek word a 1/2 ii plus or minus ii to the first ioi, which in turn originates from a 1/2 ii per mil I and I plus or minus a 1/2 iiy. Ancient and medieval era, early uses of water power date back to Mesopotamia and ancient Egypt, where irrigation has been used since the 6th millennium BC and water clocks had been used since the early 2nd millennium BC. Other early examples of water power include the Qanat system in ancient Persia and the Turpan water system in ancient China. Greek/Hellenistic age, the Greeks constructed sophisticated water and hydraulic power systems. An example is the construction by Eupalinos, under a public contract, of a watering channel for Samos, the tunnel of Eupalinos. An early example of the usage of hydraulic wheel, probably the earliest in Europe, is the Purikura Wheel. Notable is the construction of the first hydraulic automata by Ctesippus and Hero of Alexandria. Hero describes a number of working machines using hydraulic power, such as the force pump, which is known from many Roman sites as having been used for raising water and in fire engines. China, in ancient China there was Sun Tzuo, Ximenbao, Dushi, Zhangheng, and Marjan, while medieval China had Su Song and Shen Kuo. Dushi employed a water wheel to power the bellows of a blast furnace producing cast iron. Zhangheng was the first to employ hydraulics to provide motive power in rotating an armillary sphere for astronomical observation. Sri Lanka. In ancient Sri Lanka, hydraulics were widely used in the ancient kingdoms of Anuradhapura and Polonnaruwa. The discovery of the principle of the valve tower, or valve pit, for regulating the escape of water is credited to ingenuity more than 2,000 years ago. By the 1st century AD, several large-scale irrigation works had been completed. Macro and micro hydraulics to provide for domestic horticultural and agricultural needs, surface drainage and erosion control, ornamental and recreational water courses and retaining structures and also cooling systems were in place in Sigiriya, Sri Lanka. The coral on the massive rock at the site includes cisterns for collecting water. Large ancient reservoirs of Sri Lanka are Kalawa, Parakrama Samudra, Tisawawa, Minaria, innovations in ancient Rome. In ancient Rome many different hydraulic applications were developed, including public water supplies, innumerable aqueducts, power using watermills and hydraulic mining. They were among the first to make use of the siphon to carry water across valleys, and used hashing on a large scale to prospect for and then extract metal ores. They used lead widely in plumbing systems for domestic and public supply, such as feeding thermi. Hydraulic mining was used in the gold fields of northern Spain, which was conquered by Augustus in 25 BC. The alluvial gold mine of Las Medulas was one of the largest of their mines. It was worked by at least 7 long aqueducts, and the water streams were used to erode the soft deposits, and then wash the tailings for the valuable gold content. Modern era, Benedetto Castelli. In 1619 Benedetto Castelli, a student of Galileo Galilei, published the book Della Misura della Correnti, or On the Measurement of Running Waters, one of the foundations of modern hydrodynamics. He served as a chief consultant to the Pope on hydraulic projects, that is, management of rivers in the Papal States, beginning in 1626. Blaise Pascal studied fluid hydrodynamics and hydrostatics, centered on the principles of hydraulic fluids. His inventions include the hydraulic press, which multiplied a smaller force acting on a smaller area into the application of a larger force totaled over a larger area, transmitted through the same pressure at both locations. Pascal's law or principle states that for an incompressible fluid at rest, the difference in pressure is proportional to the difference in height, and this difference remains the same whether or not the overall pressure of the fluid is changed by applying an external force. This implies that by increasing the pressure at any point in a confined fluid, there is an equal increase at every other point in the container, that is, any change in pressure applied at any point of the fluid is transmitted undiminished throughout the fluids. Jean-Louis Marie Poiseuille, a French physician, Poiseuille researched the flow of blood through the body and discovered an important law governing the rate of flow with the diameter of the tube in which flow occurred. In the UK, several cities developed citywide hydraulic power networks in the 19th century, to operate machinery such as lifts, cranes, capstans and the like. Joseph Brummer was an early innovator, and William Armstrong perfected the apparatus for power delivery on an industrial scale. In London, the London Hydraulic Power Company was a major supplier, its pipes serving large parts of the West End of London, City and the docks, but there were schemes restricted to single enterprises such as docks and railway goods yards. See also, affinity laws, Bernoulli's principle, hydraulic engineering, hydraulic mining, open channel flow, pneumatics, International Association for Hydro-Environment Engineering and Research, Notes. References, Rashid, Rushda. Morlan, Ra. Copyright JIS, Encyclopedia of the History of Arabic Science, London, Routledge, ISBN A978-0-415-12410-2. External links, International Association for Hydro-Environment Engineering and Research, National Fluid Power Association, Pascal's Principle and Hydraulics, The Principle of Hydraulics, IAHR Media Library web resource of photos, animation and video, Basic Hydraulic Equations, MIT Hydraulics Course Notes.